Welcome to another video lesson on the distance formula. So we're going to talk about distance on the coordinate plane today. So we have two learning targets. First, we're going to derive the distance formula. Derive just means come up with, so create. So we're going to create it, which is pretty cool. And then we're going to use that formula to find the distance between 2 points on the coordinate plane. So a connection to history, the Cartesian coordinate system, which is like a graph, was developed by the French philosopher and mathematician René Descartes in 1637 as a way to specify a position or a point on a plane. So rumor has it he was laying in bed and wanted to figure out where a fly was at on his ceiling, and so he created the coordinate grid to be more specific about where something was located, and that's how I use it today. So in the previous activity, we've used number lines to determine the distance to locate the middle of a segment. But now a number line is a one-dimensional coordinate system. Now we're going to look at a two-dimensional coordinate system, which is known as the coordinate plane. Here is an example of a coordinate plane below. You've seen it in your previous math courses. So you're going to use the coordinate plane and follow the steps below to determine the distance between points P at 1, 4 and point Q at 13, 9. So you are going to work on 1, 2, and 3, and 4, which is on the next page by yourself because you're not with a partner. So you're going to try 1, 2, 3, and 4, and then you're going to press pause, and we'll go over it. But remember, when we read math, the notation P1, 4 means that point P is located at coordinates 1, 4 on the coordinate plane. Okay? All right, try 1, 2, 3, and 4, and then we will go over our answers. Okay, so this is what your graph should have looked like. On number 1, it wanted you to plot the points, 1, 4, and 13, 9. So you should have drawn a dot, make sure you label the point P, make sure you label the point Q. It will also help if you write their coordinate points in parentheses near them future on in this lesson. So if you haven't written the order pairs, go ahead and write that. It wanted you to draw a line connecting them. Hopefully you got a straight line. It wanted you to draw a horizontal line segment, which is left to right, and call it P and then R. So if I draw a horizontal segment, I've got a line going to straight across. The other point is our R. The vertical line segment was Q and R, so an up and down line for vertical, to create a right triangle PQR with a right angle at R. So basically it wanted you to create a vertical and a horizontal line so that where they connect is a right angle with a little lovely box of R. Okay? So we can always create a right triangle from a diagonal line by just drawing a horizontal segment and then a vertical segment. And then 13 wanted you to tell me where R was located. R is going to be located at a 13, X value, and then a Y value of a 4. Okay? So that was 1, 2, and 3. So let me know if you have any questions about creating your right triangle or finding the order pairs. But on 4, on the back page, it said, what is PR, the length of the horizontal segment? PR was the length of a 12, and QR was the length of a 5. And then it said, well, how did you figure that out? One way you could have said, I just counted the units. So for example, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can count. Or you could say, you took the absolute value of the difference between the X and the Y coordinates. What that means, going back to segment addition postulate, if I look at my X values, I could subtract them. So you could do 13 minus 1 to get 12 units. Or you could do 1 minus 13, but we have to make sure to take the absolute value because segments cannot be negative numbers. So 1 take away 13 is a negative 12. Again, take the absolute value to get a 12. So you can subtract your X values the same as your Y values. We can also subtract them. 9 minus 4 is 5. Okay, so you can either count to find the distance or you can subtract the X and Y coordinates and always make sure to take the absolute value because segments can never be negative. All right, so that's 1, 2, 3, and 4. Let me know if you have any questions because this is going to come back to help us in the next question. So let's move on to number 5. Number 5 says, use the Pythagorean theorem to find the length of PQ and show our work. So let's take a look at this math tip over here. It says the Pythagorean theorem states that the square of the length of the hypotenuse of a right triangle is equal to the sum of the squares of the lengths of the legs of the right triangle. In other words, for a right triangle whose hypotenuse is C, remember the hypotenuse is the slanted longest side, and the legs A and B, A squared plus B squared equals C squared. So that's our formula we've learned in previous classes. It's a little backwards, but that's kind of fine. So first off, I'm going to write the formula. I'm going to write it how we're used to saying it. A squared plus B squared equals C squared. So the reason I'm allowed to use the Pythagorean theorem is I have a right triangle, and you can only use the Pythagorean theorem when you have a right triangle. So here is a leg of the triangle, here is a leg of the triangle. Doesn't matter which leg comes first. The hypotenuse is the side opposite of this 90-degree angle, PQ. So I'm trying to find PQ because I don't know it, but I do know my legs, which we found on number 4, that the leg was 12 and then the leg was 5. So if I want, I can put 5 here, kind of mess that up, 5 and 12, and I don't know the diagonal piece. So I'm allowed to do the Pythagorean theorem to find that. So for A, I'm going to put 12. It does not matter which one you put first. So 12 squared plus 5 squared is going to equal C squared. Okay? To solve this, you could type this in the calculator just how it is, 12 squared plus 5 squared, or we can kind of break it down and work it out. So 12 squared is 144. 12 times 12. 5 squared, 5 times 5 is 25, is going to equal our C squared. 144 plus 25 is 169, is going to equal our C squared. So I'm not done yet. I have to get C by itself. I have this exponent of a 2. The opposite of squaring something is going to be square rooting something. Okay, and that's a symbol for a square root. So I'm going to square root both sides. Okay, the squared and the square root will cancel each other out, leaving you with just C equals, and then the square root of 169 is going to be 13. Okay? So that is how we use the Pythagorean theorem to find the length of a missing side. Okay? So attend to precision. What is the distance from P to Q? I know it is 13 units because I just found it. How do you know? I just did the Pythagorean theorem and found it. Okay? Number 7, how do we know that our triangle that we drew in item 2 is a right triangle? So let me look at this triangle again. Instead of saying it looks like a right triangle, the slope of this line is undefined. It's a vertical line. The slope of this horizontal line is 0. And when you have opposite reciprocal slopes, back to algebra, I know I have a right angle. So let's go ahead and type that. We're going to write in number 7 would be if one side of a triangle is horizontal and the other side is vertical, these sides are going to be perpendicular, and therefore I know they're going to intersect to create a right angle. So in your own words, put something along the lines of if you have a horizontal line and a vertical line, they're going to intersect and make a 90-degree angle. Okay? All right, on number 8, press pause if you need to write that down, by the way. But on number 8, you're going to be talking about the relationship that you notice among the coordinate points of P and Q and R. So to do that, I want you to flip back, and let's look at our triangle that we drew. I want you to see what you can realize about P's coordinate point, R's coordinate, and Q's coordinate point. They have something in common, so think about what they have in common and jot your answer down for number 8. So press pause and write something that you see that is the same between P and Q and R. So hopefully you said something along the lines of the x coordinates of Q and R are the same, and then the y coordinates of P and R are the same. So let's take a look at that real quick. If I look at P and R, they have the same y value of a 4, and if I look at Q and R, they have the same x value of a 13. Okay? So the reason for that is if they're in the same vertical line, they're going to have the same x value because your x value is not changing, only the y values are changing. If you have a horizontal line, your y values are going to stay the same because it's not moving up or down, it's only moving left to right, which is going to change your x values. Cool? Cool. All right. So, y'all are going to try number 9 and number 10 now. So go ahead and press pause, and you may need to do it on a separate sheet of paper because it doesn't give you a ton of room to write on this. It actually gives you none. So if you can try 9 and 10 on a separate sheet of paper, 9 wants you to explain how you would find the distance, so don't actually find the distance, just explain how you would do it. And then on number 10 actually wants you to find the distance between those 2 points. Okay? All right, so try 9 and 10, press pause, and we'll go over the answers. All right, so let's talk about how you would find the distance between 2 points. Again, we're kind of summarizing what we just did. So first off, you would plot points J and K on the coordinate plane. Okay? Then you would draw a horizontal segment and a vertical segment, connecting them to create a right triangle. Next, you would count the vertical and horizontal lengths. So you would find the legs of your triangle. Then you would use the Pythagorean theorem, a squared plus b squared equals c squared, to find the length. And if you did it, which you didn't have to, you do get 10. Okay? So let's actually work through that together because that probably was confusing for you guys. So you just need to draw a rough sketch of a coordinate plane. So an x-axis and a y-axis. Okay? Plot the points where you think they would be. So M is at a positive 9, then a negative 5. So I'm going to go to the right 9, down a 5. M is somewhere over here, located in the 4th quadrant. Same thing for N. N is at a negative 11, then a positive 10. So N is located somewhere to the left 11, then somewhere up 10. Okay? So that's how you would draw a rough sketch of a coordinate graph if you did not have graph paper. So the next thing I'm going to do is draw a horizontal line and a vertical line. So I can do it going left and right, or you could do it going up and down. Okay? So to find your horizontal value from left to right, you have to look at your x coordinates and ask yourself, well, how did they go from a negative 11 all the way to a positive 9? Okay, so you can either subtract them and take the absolute value, or you can figure that out. I'm going to subtract them. So 9 take away a negative 11, 2 negatives become a positive, and 11 plus 9 is going to be 20. So this is 20 units long. Another way you can think about it, from a negative 11 to a 0 is 11 units, and then from 0 to 9 is 9 units, therefore I traveled 20 units. Okay? To find your vertical value, we're going to take a look at our y coordinates because the vertical is change in y. So I'm going to ask myself, well, how did they go from a positive 10 all the way to a negative 5? What is that distance? So again, we can subtract them. 10 take away a negative 5. Always make sure to take the absolute value, but I do get 15. So I know that vertical distance is a 15. Again, you can take a look out of it from going from a 10 to a 0, that's 10 units, and then going from a 0 to a negative 5, that's 5 more units. 10 plus 5 is 15. Okay, so I now have my legs of my triangle. I know the up and down length is 15, and the left to right length is 20. So now I can use the Pythagorean theorem to find my answer. So let's do that. Does not matter which one you do first. I'm going to do 15 squared plus 20 squared equals my C value, which I do not know. Hold on a second. Let me get a calculator. 15 squared is 225 plus 20 squared. It's going to be 400. It's going to equal C squared. So 225 plus 400 is going to be 625 equals C squared. Square root, and that is how they got 25. Okay? All right, so that is how you would find the distance between 2 points on a coordinate plane. So again, let me summarize. You would plot your 2 points. You next need to find your vertical distance, which is your y values. Then you need to find your horizontal distance, looking at your x values. Remember that number is always positive because distance can never be negative. Once you have the 2 distance for your horizontal and vertical length, then you would substitute them into the Pythagorean theorem. Lastly, square root to find your distance. Okay? All right, so that is how you do the distance without the distance formula. In the next video, we're going to figure out the distance formula to kind of save us some time and not do all this work. So tune in for part 2 so we can derive the distance formula.